In the last lesson we were looking at the pros and cons of various types of fuels, and in particular we were comparing the use of petrol and hydrogen as a fuel for driving cars, for example. And well, we learned that hydrogen actually is a very useful fuel because it produces more energy per gram than most other fuels. So when hydrogen burns, it reacts with oxygen to produce water, which is good news. That makes hydrogen a clean fuel. But being a highly exothermic reaction, this results in a whole lot of energy being produced. So hydrogen results in 240 kilojoules per mole, which results in 120 kilojoules per gram, which is nearly 3 times as much energy per gram than petrol. Okay, in the previous lesson we were really talking about using hydrogen in a conventional car engine. So what's happening is the engine is converting chemical energy stored in the fuel into heat, and the heat is then changed into kinetic energy. Okay, that's what happens in any conventional car engine. The problem is, in this type of energy conversion, which involves releasing heat and then using that to produce kinetic energy, is that a lot of the heat escapes, is lost. So this type of energy conversion can have an efficiency as low as 30%. So a lot of the energy in this reaction is wasted as heat, it's not converted into kinetic energy. So there's been a big drive to look for more efficient ways of obtaining this energy, and one of those is by using something called a fuel cell, which is what we're looking at in this lesson. So fuel cells, in a sense, make use of exactly the same reaction, but use clever chemistry to avoid energy being lost in the form of heat. So in a fuel cell what happens is the chemical energy is converted directly into electricity, which is then converted into kinetic energy. Okay, so we've got conventional engine and a fuel cell, and that can result in efficiency of up to 80%, so much better efficiency with a fuel cell than a conventional engine. And so there's been a lot of money invested in the development of these fuel cells in recent years. So let's just have a look at a basic fuel cell and see how it works. Okay, let's just label it to start off with. Okay, this is basically like any electrical cell, so it has an anode. Remember, in electrical cells the anodes are negative, whereas in electrolysis they are positive, cathode. And in between the anode and the cathode we have the electrolyte, which also acts as a membrane, and the membrane prevents the gases which are going to be coming in from either end of the fuel cell from diffusing across the electrolyte. Okay, so this electrolyte also acts as a membrane, and so we've got hydrogen gas coming in here. Okay, so let's just follow the equation we've got here. So we'll put 2 hydrogen molecules coming in here. So we've got a hydrogen molecule there and a hydrogen molecule here. What's going to happen is these anodes and cathodes are actually also catalysts. So as the hydrogen molecule diffuses across the catalyst helps the hydrogen molecule to break down into its individual hydrogen atoms and help each atom to release an electron. Okay, so as a result of the work of the catalyst, we're going to have 4 hydrogen ions. Okay, so each of these hydrogen molecules will release 2 electrons. There we go, they release 2 electrons and produce 4 hydrogen ions. The electrons will then pass around the circuit, okay, from the anode to the cathode. So that's right, that's the electron flow. And in the meantime the hydrogen ions will diffuse across the electrolyte to the cathode. We've got the oxygen molecule. Likewise, the oxygen molecule, as it diffuses through the cathode catalyst, forms an oxygen atom and an oxygen atom. The hydrogen ions, when they reach the catalyst, will pick up electrons from the circuit to form hydrogen atoms again. There we go. The hydrogen atoms will then join onto the oxygen to form water molecule and a water molecule. Okay, so we've got 2 H2O coming out this end of the fuel cell. So we've got 2H2 going in, O2 going in this way, and that's producing 2H2O coming out of this exit. Okay, so what's happening then is that in the fuel cell we're making use of exactly the same reaction, but the 240 kilojoules per mole is being released slowly to produce electricity rather than directly to produce heat as in the conventional car engine, and this results in a much more efficient form of kinetic energy production, which is exactly what you want if you want to power a car.